Neglected to give you the fill in the blanks here for this equivalent symbolic rules definition, but it's the same. Two symbolic rules are equivalent if identical input values produce the same output values. So again, identical input values producing the same output values. So these again are not equivalent. So let's go on to the next example here. Talking about your drive to work. So I want you to read this. Stop the video now and read it, and then we'll ask some questions. So read it now. Alright, let's take a look at question number 2. Here, how would you calculate your total mileage to and from work on this day here, supplied in this situation? So consider the following two possible verbal rules that could illustrate the relationship between these two variables. Now the variables are defined pretty clearly here. The input variable here is the usual one-way mileage, and the output variable is the total round-trip mileage. So you have this obstacle or this detour that you have to go, and it's causing you to travel 5 extra miles in both ways. So here are two possible ways, ways to describe how you could calculate. And I'll give you a hint. One of these is right, one of them is wrong. So this is what we're going to challenge you in your reading here in this section with. So these are just possible, and you probably may have a feeling of which one's right. But let's take a look here. This usual one-way mileage. Let's say it's something easy like 10 miles. So using this first one, if we were going to calculate the output variable here, notice how I wrote down what the output variable is. It's a total round-trip mileage, and the input here is the usual one-way mileage. So that's a good thing, a habit to get into, is to write down what the variables are immediately once you read them in your situation. So let's say your usual one-way is 10 miles. If we were to use this, what would we get? To obtain the output, or this guy, double the input, so double that, times 2, and then add 5. Because of the 5 additional miles, we could think of it that way. So that's 20 plus 5, or 25. Let's do another one, just to get a feeling for this verbal rule. Let's do 6. Let's say it was 6, so you live close. So this verbal rule says we would double that, because you're going to and from, and then you got to add 5 because of the detour. So that's 12 plus 5 equals 17. And let's do one more. Let's do 50. So you got to go across town. So we're going to double that and add 5 because of the detour, so that's 100 plus 5, or 105. So we're just utilizing this verbal rule given to us, and we're calculating here. So let's look at this one. To obtain the output, meaning this total round trip, add the input and 5, then double the result. Well, what would that look like? Well, if I took 10 and your one-way mileage there, 10, and I add 5 to it, and then double this, so multiply by 2. Now if I leave it like that, it looks like just the 5 is being multiplied, but I want to actually double the addition of that 10 and 5. So that's 15 times 2 equals 30. So the question is, which one's right? Well, hopefully you can see that this 5 extra miles is occurring in both directions. In other words, you don't just add 5 once, you add it twice here, and so you got to add it to your usual one-way mileage and then multiply by 2. So I'll give it to you here. This one's actually the right one, but let's say you live 6 miles away and you got to add that detour, but then it's both ways, so that's why we multiply by 2. So that would be 11 times 2, or 22. And then using this verbal rule again with the 50 guy, we have 50 plus 5 times 2, or 55 times 2, or 110. Okay, so